Okay, shall we start? Okay. Um, okay, so today we're gonna be splitting the class to three parts. The first part is to revise our Hangman homework. Okay, I'll go over not everyone's work, but I will go over the work with you. And then the next thing we're gonna talk about is structured data. Discuss the importance of so-called structured data. And lastly, we'll talk about Pandas, which is a very useful library for structured data. Before we start, just to mention, I've sent out a class video to you guys. I hope this will be useful because I record every single lesson. And if you miss it or if you don't understand the class, you can always go over the video. Okay. Okay, we'll start with the Hangman homework. It should be in this workbook. I hope everyone have it. DSML 4, week 1 solutions. Okay. So I went over everyone's work, and well, as you can see, your work should be on the notebook if you hand it to me. And what I did is I list everyone work and sort it by how long is the code. Okay, I think the whole point for showing you this is, one, there are a lot of ways to solve one single problem in Python, and two, you can try to look at other people's work. And the reason for that is because if you're working in Python, you realize it's so easy to look at your own code, but it's so hard to look at other people's code. Okay, so by looking at this, you probably realize best practice for coding is, one, name your variable clearly. Okay, and two, try to put a lot of comments. And three, is when you look at other people's code, try not to read it line by line. Okay, try to read it by the entire structure. And I'll explain to you what I mean by reading the structure. But if you look at the first cell, I think this is the best answer overall. You can see the code is very short. It's like 27 rows, while our longest code is like around 87 rows. Okay, I'm not saying the always try to squeeze your code into very few lines, but Python has a philosophy that try to write everything as simple as possible. Okay. Before I continue, does anyone has a problem finishing the work for Hangman? Okay. Do I need to go over the logic for Hangman? Should be alright, right? Okay. So okay, just try to go through the first one very quickly. You can see why this is very good, because clearly it has two parts. The first part is just to select the variables, randomly select the words, okay? And the second part, everything is wrapped within 10 lines or 14 lines, okay? And the logic is very simple. This one is just for every one of the words, just check whether or not it matches with the guess. And the second logic, it's if your word is equals to the choice of word, then you won. Okay, basically it's just as simple as that. But I've seen a lot of a lot of code with very complex structure and a lot of nested loop. Not saying this is bad, but try to look at it. You have one indentation, two indentation, three indentation, 4 and 5. Okay, this is so-called the nested loop. And in computer science, if you have a loop out of a loop out of a loop, then it's gonna be slow. Okay, try not to do something like this. And part of other things. Okay, this is another code that I really like. The reason is the comments. Okay, it's very clear. Every line has a comment, and every variable is quite self-explanatory. Okay, what it means by self-explanatory is if you look at the variable hidden word, you know what it meant, and like guess letters, you know it's a letter that you input to guess. Okay, so just some important points for you to take away from the homework. Any questions for the hangman problem? Okay. Okay. Apart from the hangman, we have another second challenge, which is the maximum subarray. Not many people submitted this work, but this is the interview question for my company, and you're expected to finish it in 5-10 minutes. And I saw some work submitted, but they're not really solving the questions. So I'm gonna go through here pretty quickly. Alright, so the challenge is to find one of the subarray that gives you the biggest sum. Okay, what it means by subarray is not getting like from the beginning, like the first 3, first 4, first 5. It doesn't mean subarray. Subarray means any combinations that is connected to each other. Like this is a subarray, or this is a subarray. Okay, so basically I have to find the combinations that give you the biggest sum. Okay, how would you do it if this is an interview? What are you gonna do? Okay, basically this is just a loop. Okay, but it doesn't loop one way, it loops 2 ways. Okay, it loop from the beginning, and it also loop backwards. So let's say if I do for I in A, and then right, let's say for I in range A, range length A. Okay, if I do it this way, it's gonna print it out all the index, right? And if instead of the index, I print out this. Oops, sorry. Okay, it's gonna print out all the array, but it all starts with the beginning. Okay, so what you need to do is try 2 loops for R in range length A and try to do the same. So you have I and R. Okay, now in this case you're trying to the exact term is brute force, I think. So try to find out all the combinations of the list. Alright, now that you have these combinations, what you need to do is just try to find out the sum of all of them, because all you need is the biggest one, right? The biggest sum of the subarray. Then, okay, basically just try to do something like begin M with something like okay, again, M is the first string, and then you do if M is smaller than sum A I R, okay, actually that's not solving the problem, but okay, I think we have to do another one, because if I do it this way, I won't remember which subarray has a bigger sum. So I have to add another empty string that keep on storing the subarray, and then find out by the index. Okay, actually, let me have a peek of my previous answer. Yeah, that's what I do. Okay, maybe better look at this one, because this one I'm sure I have the answer. So first line is the first loop, second line is the second loop. This one is just looping every combinations, and then for this line, I'm just storing all the combinations into a list. Okay. Okay, let me go back up. Sorry. Alright, okay. Remember how I did it. Alright, go back to this one. So I am storing L dot append A I R. Okay. Okay, and I'll just stop printing out this one. So now, if you look back to your L, it's basically storing all the combinations. All right, and at last you only need one more line. That is I for I in L if sum of I equals M. Okay, that's the answer. So what's the last line does? Okay, it's basically you have L and you have M, and M is basically the biggest sum, right? Okay, maybe let's put it this way. Everyone understand what's L? Alright, and if you want to find out the biggest sum out of them, how can you do it?
Sum all the digits.
Yeah, sum all the digits for every single list, right? So it would be for I in L, try to do a sum, right? And if you print this out, it's gonna be like this, a lot of sum. And if you want to find out the biggest one of them, you can do it with a so-called a loop comprehension, and then just find the max of it. Okay, does it make sense?
Sorry, actually, this actual question is the thing I'm not actually sure what's going on, because are you trying to basically find in the order of A?
Yeah.
In order, like the biggest sum, because I don't get why. I'm not sure how I would have normally found that 4 minus 1, 2, 1. Is trying to are you trying to say, in this list of number, let's find the biggest sum, but it has to be all connected? Because I wasn't too sure what we were doing.
Basically, I don't know what's the biggest sum.
Yeah.
Right. So the first step is to find the biggest sum.
Yeah.
And so I just loop through all the combinations and find out from all the combinations which one are the biggest sum.
Okay. Because I was just confused, in the terms of, because I didn't get how to find the biggest sum of a list.
Okay.
Because this is a bunch of numbers. I mean, surely the best way would be pick. I don't know, because I was thinking 4, why stop at 4 minus 1, 2, 1? Why not just pick the 2 4s? I was not too sure.
Sorry, I didn't mention this. The definition for a subarray,
Yeah.
it has to be connected.
Oh, okay,
Yeah.
that's fine. Okay.
So you can't just pick
Yeah,
out
no, I was
four
very
and-
confused. What is the definition of the biggest sum?
Okay.
No, I get it
Yeah.
now when you mention it.
Okay. Does it make sense for everyone? Please say no if it doesn't make sense, so I can keep on explaining. So basically, this L. Everyone understand this? Okay. And what I need to do is I will try to get the sum of every single one of this sublist. Okay, so this one will be -2, this one will be -1, this one will be -5, this one will be 0, and one of them will have the biggest sum. And I have to find out which one of them. Okay, so basically I have to do for I in the list, find out the sum. But if I want to output this entire thing into a list, I have to do it this way. Okay, and I basically find the maximum out of it. Okay, and then I have to find out which one of this list has 6 as a sum. So I have to do it this way. I for I in L if sum of I equals 6. Then that's the subarray I'm looking for. Okay, not many people are nodding their head.
Okay, so in the for I in L, if sum of I equals to the M,
Yes.
which part of it picks it so it's a subarray of numbers? Like I understand what subarray is now, but like how would you? What is the line that makes it so it's finding a subarray rather than just random numbers?
All right. Let's go back to our first these codes. Okay. If we print out this, okay, let's go back to the very top. We have A, which is our problem sets. If you want to find out the subarray, you have to do 2 loops. One loop from the beginning, and the other one loop from the end.
Okay.
Okay, and that's printing out this guys. Oh, sorry. Okay, because you're looping it I, and then looping for R, and then just put the 2 index inside the list.
So it's like it'll sort of from
Yeah, you just loop from this way and loop from this way.
Okay, until they sort of meet.
Yeah.
Okay.
And that's how it looks like visually. And then if you want to store everything of this into like a list, you just put it like this, right? Okay, and now L is basically what you printed out.
Oh, okay.
Okay.
So then L is basically the sum, like every combination we have.
Yes. Okay, now that we understand what's L, and then we just try to find the sum out of all of these little list of list. Okay, these guys are called list of list because we have one big list storing all these little lists. And if you do like the first one is something empty, the second one, and the third one, and the fourth one, okay, and basically just go through I for I in L and do the sum. Okay, that's how you do sum, and that's how you do the maximum. Okay, now that we know that the maximum is 6, we just do for I in L if sum of I equals 6, just print out I. Okay, that's how you get the answer. Okay. Basically programming is just, I think 80% of them are just loop and if. Okay, if you know master if and then loop, you can solve 80% of the problem. And basically for hangman and for these questions, all you need is just a loop and a if. Okay, if you think about it, it just solves everything. So if you can't solve this substring problem, try to look at the answer, and think about it. And yeah, I can write up some simple exercise to break down the questions so you can understand it better. All right. Okay, just one question. Are you guys comfortable with Python overall? If not, we can spend some time to a recap. What do you guys think? Do you guys need a recap of like loop, if, everything? Okay. Probably you guys are quite good. Let's skip the recap and do the test, because I have some test of concepts that you guys might love to do. Okay. Okay. Now start the test. Okay. First questions. Okay. Sorry. Okay, can you fix the bug in here? What's the problem?
The colon.
Sorry?
Dot.
Okay. Okay, first problem is the colon. Okay.
You have to push the print.
You have to push this.
Print, both prints.
What should I press?
Space.
Space or tab. Okay. So either for space or just do a tab. Okay. Okay, now it works. Okay, so the first one is done. Second one, in a Python memory system, what is variable s after you execute the code? And x, and which variable is assigned as 24? Okay, now we have first line is x equals 12, second line s equals 1, and then we have a function. Okay, in the function we do s equals 10, x equals x times 2 plus s. And then I print out the x, return the x, and then I execute a line. This is a function 7. Okay, is there any... Okay, first question, what is s?
That's be 10.
Okay, now I execute the code. Okay, moment of truth. Anyone say it's 10? Okay. S is 1. Okay. S is not 10. Anyone know why?
Because it's outside of the code. Only within the code is S10 for the purposes of doing the calculation of the definition.
Yeah, so basically S is assigned as 1, and inside the function, everything inside the function doesn't go out. Okay? Think of it like one country, two system. Okay? Function is like Hong Kong, and the whole thing is like China. And Hong Kong and China has different system, different rules. Everything happened in China, in Hong Kong, doesn't really apply to China. But everything in China, most of the time, apply in Hong Kong. Okay, so everything outside the function is like the global variable, and everything inside is the local variables. Okay, so what's x? The second questions. X. Who thinks x is 12? X is 12. Who thinks x is something else?
I think it's 24.
Okay. Moment of truth. Okay, x is 12.
Because I thought you returned it when.
Because I didn't define anything as x, right? Okay. And which variable is assigned as 24?
This is a function.
The result of
X is not assigned. So actually, nothing is assigned as 24 in here. Okay. If I do it this way, x, then x is 24. Okay. So again, like this is designed to confuse you, okay? Because everything in X, everything inside the function, it just looks like this guy is the same as this guy, right? But in reality, it isn't. It's just how you name variable inside the functions, okay? Remember, everything inside the function don't go out unless you make it go out, okay? And it's not a good practice to define any variables that goes out of your functions, okay? So, okay, just third question. Now I have a very long list. Okay, try to make it shorter. The question is how to get the second last object of the list.
X minus 2.
X minus 2. X minus 2 like this.
Have a square bracket.
Square bracket. And then minus 2. Okay, cool. And how do I get the length of the list? Length X, right. Okay. It should be right. 99, this minus 31. Yep.
What happened?
Sorry?
I was just confused. Wouldn't the length X be 2?
Oh, length of X is not 2.
Oh no, sorry. I was
It's,
thinking X. I didn't read the range.
this one, 9968. Okay, let's go on quickly. Okay, now you have two lists. How do you concatenate the two lists?
A plus B.
A plus B.
C equal to A plus B.
Okay. So now C is just a very long list. Okay, a longer list with A and B concatenate. Now multiple every item on the list by 3. How can you do it?
C star 3.
Okay. Any objections?
For I in C, I multiply by 3.
Okay. I'm sorry. I heard for I in C, and then
I multiply by 3. Return
I multiply by 3, and then that's it. Okay. So for this, it doesn't print out anything, but let's say if I print it, okay, this works. But how about C times 3? It's gonna be a very long list. Okay, Python doesn't work that way. But remember NumPy, which we learned last class. Just import NumPy as np, and then you do np.array. Okay, now you can do it like this. All right. Yeah, you can do a list comprehension. How can you do a list comprehension? Square bracket. C. Okay. Now it's 3, 6, 9, 12. Okay, it works. Everyone understand what's a list comprehension? Anyone don't? Okay, if you don't, I'm gonna send this out to you. So basically, it's just a walkthrough, teach you all the basic list stuff. For list comprehensions, it's basically a structure like this. Okay, everything wrapped up with a square bracket, meaning that the output would be a list. Okay, and then, okay, this is actually making it more complicated. Everything you want to execute comes in here. And then, you know, for every single loop, you have to do like for I in X or for E in the list. That part goes into here. And any optional conditions, do it at the end. Okay, if something happens. And the reason for this to be nice in Python is you can do it in one line. Okay, let's say if you want to do it without these comprehensions, you have to do like 3 or 4 lines of code. Okay. Okay, let me send you guys this homework after class, and then we'll discuss it again next class. Okay, let's keep on with our quiz. Okay, can you fix the bug in here? I want to concatenate x and y. What can you do? So I want a list of 1, 2, 3, 4.
Turn y to a list.
Yeah, turn y to a list. And you can do it this way, or you can just put the square bracket underneath. And now you can do the concatenations. Alright, I think... Okay, can you fix the bug in here?
Remove the comma.
Remove the comma. Okay. What else can you do? Okay, probably this one is too hard, because you have to do this. For list comprehension, if there's an if else, you have to put it in front. Okay. Okay, last questions. Can you fix the bug in here?
Move the 4 in front.
Okay, move the 4 in front. Where should I put?
A, between A and if.
Okay. Like this. Okay, that's how I do it. I hope this is helpful for you to understand like what's the key concept you're missing. Okay, probably you guys need more exercise on the basic stuff. But once you know this stuff, it's gonna be very useful. Okay. Okay, let's go back to our DSML class 3. So we discussed our homework, and let's go to so-called structured data. Okay. There's a link under data structure, and just bring you to a different page. Okay, it should load. Okay. Okay, so this data structure is basically tell you what are the different ways to store your data. Okay. So you can think of all the data structure like this. So basically everything on the left is very old. Okay, everything on the right is very intelligent. Everything in between is not very good. Okay. What's a key value? A key value is like a key with a value. It's like a lookup table. Okay. And the ordered key value is a table with the key in the order. And you can expand this to a bigger table, and if there are a lot of bigger table, you can put it this way. But the best way to store data would be something similar to SQL. Anyone know what's a SQL? Or anyone heard of the term SQL? Okay. What it means by SQL is a huge database. Okay. And what's so special with SQL is basically it just split your data into many different tables and just merge them by keys. And this is a very good way to manage a large amount of data.
Sorry, what is SQL stand for? Why you pronounce it as SQL?
SQL.
Is it sequence?
I think it's I can't find. SQL stands for Standard Query Language or Structured Question Language. Okay, I don't know the answer for this, but I can research it for you. Yeah, but just good to know. We won't teach you SQL in here, but just to have this in mind when the data goes very large, use SQL. And then, okay, we have another type of a data structure called a CSV. Okay, anyone knows what's a CSV? Yeah, comma separated. Probably when you like working with Excel, sometimes the file doesn't end with XLS. It ends with CSV, and then the structure would be very standardized, but without all the colorings and all the formatting, and that's CSV. And CSV is like the probably the best data structure for data science. Okay, because it shows things in a table format. Okay, and I'll teach you how to open the CSV. We also have something called the XML. Okay, if you don't know what's the XML, just try to go to your browser, click inspect, okay, and then you will see something scary on the right hand side, which is called HTML. Okay, these guys are called HTML, but this is very similar to an XML. Okay, and if you just roll over them, you realize they are like a tree structure. Okay, you can close it or you can open it. And let's say you open the body and then try to go over the page, and you realize as you move along, it just select very different stuff on the page. Okay, let's say I select this, and this guy is basically showing what's on the left hand side. Okay, this is called XML structure. Okay, and this will be useful when you do web scraping, and I'll teach you how to do it later on. Okay. After XML, we have something different called JSON. Anyone heard of JSON? Okay. If you deal with API a lot, this is how the data is stored. Okay, basically it's just a lot of curly bracket, but the curly bracket can have many levels. Okay, some curly bracket has more items inside and some has less. Okay, and basically this is what computer use to communicate with each other, because this is not very human readable, but it's very computer friendly. Okay, and this is just the same thing showing in an XML format. Okay, and probably this is all you need to know. And then now what we want to talk about is Pandas. Okay. Before Pandas, I think we should go over this first. Okay, and at the end of last class, there's a question set asks you to do stuff using BMI or calculate the BMI value of everyone. Basically, the BMI value is like how healthy you are based on how tall you are and how heavy you are. Okay, if your BMI is like 18.5, you're underweight. If you're between 18.5 to 25, you're like normal, and if you're over 25, you're overweight. Okay, if you do stuff using normal Python, you can still calculate BMI. Okay, try to run all the codes right here. This is similar to what we did at last class. We use NumPy to generate a bunch of random numbers, a bunch of weight, and we want to calculate the BMI for everyone. Okay, once you run all the code, it will be in a list format like this. Okay, and if you do weight, okay, it just gives you a very long list of weight, and for height, it gives you a very long list of height. Okay, but this is not easy to manage. Okay, now you have 3 lists and everything just scattered around and it generates a very long list. Okay, what happens if I want to put the 3 things inside a table? Okay, so everything is side by side and it's very handy. We do it via Pandas. Okay, because Pandas is a table format. Okay, let me switch over to this. Sorry. Okay, this is how Pandas is formatted. This is quite important, so pay attention at least on this part. So what is Pandas? Pandas is basically a lot of lists, okay? And the list is just listed vertically. And every single one of these lists has to have the same length, okay? So if you put a lot of lists with the same length side by side, it's going to form a table, right? And in this table, the column, okay, or the letters on top will be the column, will be called the column index, and everything on the left will be called the row index. Okay, just have this in mind. Everything vertical is called column. Everything horizontal is called a row. Okay, just have this picture in mind, and then we'll go over a lot of examples later on. And okay, just to let you know, this library is called Pandas. It's quite similar to the Panda, and if you want to know more about them, just click on the list, and it will show you a few links that have some very nice usage of Pandas. Very slow internet. And if you want to learn more about the syntax of Pandas, also click on this, and then it will show you like a Pandas cheat sheet. It's just like the NumPy one. And then in this datasets, it will show you how to store everything in a table, and it will also tell you what's the good thing of storing things in a table, because you can plot graph very easily. Okay. Okay, and why do we use Pandas? And the main reason is Pandas can hold something very large. Okay, if you are using an Excel sheet, I don't know if you have ever tried scrolling down Excel until it reached the bottom. In the old one, it probably stopped at like 60k rows, and in the latest one, you probably can go up to 1 million rows. But for Pandas, the limit is your computer. Okay, as long as your computer can hold it, it doesn't matter how big is the table. Okay. In here you can try with your computer. If you are confident, then you can try run this very large CSV. Okay, this CSV I think it has 7 megabytes. I tried run it on my cloud machine. It crashed my cloud machine. So if your computer has many RAM, you can try open this file. Maybe not in the class, but back home when you are with your computer. Okay, just some brief overview with Pandas. So Pandas is just a long NumPy, is in a family of scientific Python. And these are just some of the highlights for Pandas. So it's a structure called data frame. Okay, and then what's the advantage for this is you can do this very easily. So let's imagine you're working stuff on Excel. Okay, you have to cut, you have to do calculations manually, right? You have to scroll through things, or you have to cut the columns manually. And let's say if you put things in Pandas, like all the cutting or all the calculations can be done in a streamline, like a factory. And this helps you to automate your work. Okay, if your work is very Excel oriented, you probably can make use of Python and put it into a pipeline. Okay, let's say if you need to visualize some data every month, probably just put it into a Pandas pipeline, do all the cutting or restructuring, and just output your final table for data visualizations. That's how to make use of it. And if you are a bit confused with what's the data frame, this is a very nice comparison between like a Python stuff and spreadsheet style. Okay, if you define a variable in Python, let's say x equals 1, it is equivalent to just one cell on spreadsheets. Okay, if you define a list, x equals 1, 2, 3, 4, 5, it's basically just a row on the Excel table. Okay, and let's say you want to do a data frame, like pd.dataframe 111 tt2. You're basically forming a data frame like this, just table, but it has to have the same length. Okay, it has to be a structured table. If you don't do it structurally, you're making a dictionary. Okay, a dictionary is just an unstructured combination of lists. Okay, does it make sense?
The data frame is still using curly braces.
It's still doing what?
The curly braces.
Oh, you mean this?
Yeah.
Yeah, you can do it that way. You can put everything inside a dictionary, but every dictionary item has the same length. Like, you can put it to this format, but if every one of this has the same length, you can frame it to a data frame.
Can we say that it's a dictionary
Yeah.
with values of same length lists?
You can say it. You can say it that way. But there's one more layer too. Okay, let me show you an example. Okay, this is a dictionary. A and then 1, 1, 1. And then B 2, 2, 2. Okay, this is a dictionary. Okay, if you have the same length, you can do this. pd.dataframe. And it becomes a table. Okay, but if you change the length, now it's not uniform. Try run it, become error. Okay. Okay, let's keep this. Okay, this is, oh, sorry. Okay, underneath there's a example. Just example of an ordinary table. Just help you to visualize. Like this is actually a list, and this is actually another list. Okay. Probably you can't see the image on your Python notebook. I'll try to send you a newer version with the image. Okay. Okay, so what are the usage for Pandas? Pandas is particularly useful for time series. Okay, if your analysis deal with time, then put it into Pandas would be very helpful because it just plot you the graph very nicely. And Python got a very powerful function that convert every date into a very nice format. Okay, and also you can use Pandas for modeling. Not sure if you know linear regressions, but if you want to do linear regressions, put everything inside Pandas, and then you can do it very quickly. Okay, so here I'm gonna go through some very basic Pandas functions. Okay, this will be very useful. Okay, let's say the first step is to create a data frame. Okay, all you need to do is import the library. Okay, import pandas as PD. Now PD stands for pandas. So now, yeah, I just demoed this, but I'll do it again. If you want to create an empty data frame, create a library. A dictionary. Okay, a dictionary starts with a curly bracket, and every dictionary has a key. Okay, this is called a key. And if you do one, two, three. And then close bracket. Okay, it's gonna give you a dictionary. Right, and then if you bound everything with pd.dataframe with D and F in capital letter, just run it. Okay, congratulations, you have your first pandas table. Okay.
Question.
Yep.
How can I make the column index not be like 1, 2, 3? For example, if I wanted to start it by 10, like it's 10, 20, 30,
Okay.
or any other combination.
Alright, you can do it this way. Call it df. Df stands for data frame. And if you want to change the index, just do df.index equals, I don't know, whatever you want it to be, like A, B, C, and then it becomes, okay, come on, okay, now you change the index.
Okay, and then if I was to like later say, I want to find what is on row B, would it just give me 2 then?
Okay, we're gonna go through it
Sorry.
later, but okay, let's do this. If you want to find everything in row B, there's a function called log in pandas, and you can just do row B and everything. Oops, sorry. Yeah, that's correct. Because row B shows you 2. Okay, so if you do df.log B, it gives you 2. Okay, but let's worry about this later on. Okay, now you know how to create a data frame. Or you can, instead of creating your own one, you can read it from another source. Okay, let's say you have a URL with a CSV. You can just run it, pd.read CSV. Okay. And now if you run df2, it's going to show you a very large table. Okay. Any questions for now? Okay, but let's say if we are doing like data analysis, we don't want the entire table. A lot of time we want to cut it by row or cut it by columns. And how can we do it? Okay, to select a subset of a data frame. Okay, let's say I want to select column A. Okay, I can do it by dot A. Okay, now I select everything on column A. Or alternatively, I can do square bracket and then string A. Alright. And that's how you select a column. And let's say you want to list out all the columns that you have. Basically, in this case, I only have one column, so I'll run it again. Okay, let's say I want to list out all my columns. It's going to be A and B. You do df.columns. Okay, or alternatively, you want to name your column to something else. Just call it Hong Kong and Kowloon. Okay, you can just directly define it. And now I have my Hong Kong column and my Kowloon column. Okay, but let's change it back to A and B. Okay. Okay, alternatively, if you want to do it, this is more old school, but it's more proper. If you want to do it a different way, you use df.log. And then every bracket we now have two parts. The first space is the row, and the second space is the column. Okay. If you wanted to search for a column, just type in the column name. And then if you don't want to search anything, just put the colon. Okay, this is equivalent to getting the column. Or alternatively, you can search by the index. I think you can. Okay, if you do 1 and A, basically you're selecting this. Okay, how about if I want to select this guy, C? What should I do? I should put 2 here, right? 2 and B. Okay, now I have C. Alright, let's say if I want to replace this value to something else, to let's say to Patrick. You just do it like this, equals to Patrick. And then now check. I just change my value to Patrick. Okay. Or alternatively, there's another way called ilog. Okay, this might be confusing, but the I in log means index. And for ilog, instead of putting a name, you put the index number of it. So instead of putting 2 and B, you just put 2 and then just count 0 and 1. This is the first column in Python. Because this is the 0 column, this is the first column. And this is the same thing. And if you put 0, it's going to show you 3. Okay? So make sure you understand the difference between log and ilog. Okay, if you're confused, just always go back to this example. I think this should be easy enough to understand. Okay, let's say I want to create a new row. Okay, this new row is called C. All I need to do is just do square bracket C and then type in whatever I want. But this new column has to have the exact length. Okay, because I have 3 numbers, has to be 3 numbers. So let's say 0.1, 0.2, 0.4. Okay. Okay, now I have a new data frame. Okay. Alright, then after that, something more complicated. Let's say I want to do some manipulation on the data. Let's say I want to change everything on column C by ×2. Okay, I have to do. Actually, you can do it like a list, like for I in C, and then ×2. This is the list comprehension we discussed. Sorry. Okay, you can do it this way. Or alternatively, you can do it by a function called apply. Okay, what it means by apply is just applying things on your column. And you can do it like this. Dot apply inside apply, you have to do lambda x. What it means by lambda x is you have to apply something on a variable, but you haven't named your variable yet. So let's say for your list comprehensions, you name all your variables as I. And in here, I have to do the same thing. I have to name my variable. So I just call it lambda x. And what it means by lambda is just a very temporary variable. Once you use it, it just disappears. It's something called lambda. Okay, then you do x times 2. Alright, now every...
So if I'm understanding correctly, lambda is just converting your data frame into a temporary variable, so you can just do x times 2.
Yeah.
Okay.
Yeah, think of it as a temporary variable. Just like how you do your for loop. In a for loop, I is your temporary variable. Okay. Okay, now that I have done my apply, but actually it doesn't change my original datasets. Okay, my original datasets will still be 0.1, 0.2, 0.4. And the reason is I didn't define a new variable. Okay, so to change it, I have to define it. Just do it equals a new thing. Okay, once I click enter, my new variable will be inside my data frame. Okay, you can keep going, and your variable will go larger and larger. Okay. Okay, let's say I want to drop a variable. Okay, I don't want them anymore. I want to drop it. I just do df.drop. Okay, and but let's say if you want to drop something, you can drop a row or you can drop a column. Okay, so in Python, everything 0 refer to a row, everything 1 refer to a column. Okay, so if you want to drop a column, put the axis equals 1 and drop the row you want like this. Okay, once you click drop, you drop it. Okay, but remember, once you drop it, you still have to redefine your variable, unless your drop will not be executed. Okay, now you drop it. Sorry. Okay, now B and C disappear. And let's say you want to drop a row. Same thing, just drop by axis equals 0, and then select the row you want to drop. Okay, now it's just left with a very tiny data frame. Okay. Any question for now? Okay. Okay, let's say I redefine my data frame. I need a bigger data frame. So let's say df equals pd data frame, and then okay. Let's say for this data frame, I want only the first 2 lines. You can do something called head. Okay, if you want only the first 2 lines, just do df.head and 2. Okay, if you want the bottom 2 lines, just do df.tail and 2. Alright. Okay, and then the other important things, it's called the shape. Because let's say you have a very big data frame, you want to know the number of column and rows, just do df.shape. This tells you the number of rows and the number of columns. Okay, and you can have df.info Okay, this just shows you what every column is. Tells you the data type. Okay. Okay, lastly, before our break, one more, df.describe. Okay, it just shows you the simple statistics for your column. Okay. Let's take a 5 minutes break and then we'll come back.呢個其實自己揾到嘅 set， 當然你可以揀人哋揀過嗰啲，但係最好就如果有自己啲 set 就有趣啲咯，我覺得。可以 send 啲 link 佢，即係俾你揾啲 set。哦，靠個。係啊。Okay. Yes.
So, for the data set we have to pick.
Yes.
We pick it on Kaggle.
Yeah, I should talk about it in the class, but if you have a data set, you can choose any data set you have.
Okay.
If you don't, you can do it on Kaggle or just anything on the internet.
Okay.
Yeah.
Because I see in the email you sent,
Yes.
you mentioned the data set should be using for.
Yeah.
And I thought you also mentioned the Titanic data set because it was the one I had in mind.
No, sorry, I can't.
The Titanic.
Titanic.
Yeah.
Yeah.
So can we take the different because it was the one I had in mind.
Oh, you can do the same one. Yeah. Just pick Titanic so no one else can pick it.
No, I can take something else. It's not a program.
Yeah, just I don't mind you take Titanic.
Okay.
Yeah.
Okay. If I can, I take something else.
Yeah. Shall we start? Okay, before I keep going with Pandas, I send all of you an email, and in the email it says you should be searching for datasets for presentation now. And click here to fill in the datasets you want. Okay, so just a reminder, 2 classes later, you're gonna do your presentations. Okay, the presentation class would be, okay, so we have a Thursday class on visualizations, and then, okay, we can do it on Tuesday. Okay, that's 8th of May. And so before 8th of May, you should have datasets you wanna talk about. Okay, it can be any datasets, so you can bring your own one. If you don't have your own one, you can go to Kaggle. Okay, just type kaggle.com datasets. Okay, and you have a lot of data to look around. And try to pick something big and try to pick something interesting. Okay. Like in my previous class, people visualize very silly datasets. Okay, one of them visualize like FIFA 18's datasets, like visualize all the player statistics, or you can do like someone visualize a Breaking Bad, just visualize all the conversations on Breaking Bad. Okay, and then what else? Someone visualize. Not sure if you guys heard of League of Legends. So basically, just get one of the matches and visualize what's going on in the game. Okay, just pick whatever things that interest you. Okay, and what you need to do is visualize the datasets. Find out what can you find. Okay, so let's go back to our pandas. Okay, we're right here, 4.1.7. Okay, so remember we have our BMI example. So let's put our BMI stuff into a data frame. So that's bake. Okay, I don't have age, but I should have weight and gender. Okay, I probably need to go back to my datasets. Okay, make sure you run these codes. Okay, after you execute all the lines, just go back down. Sorry. And then, okay, now you should be able to execute these lines. Okay, basically all I did is I have 4 lists of data: age, weight, height, and gender. And now I put everything inside the table. Okay, just the age column, weight column, height column, gender column. Okay. And okay, here is just a line with better explanations. You can read it back home.
Wait, so it's exactly the same as the above?
Yeah, just exactly the same. Yeah. And then let's say we want to do a calculations. I define a functions above called calculate BMI based on the weight and height. So I can just do it this way. Calculate BMI, weight, and then height. Okay. Now I can calculate all my BMIs, and then I can define a new variables called BMI. Okay, now I calculate the BMI for every single row. Okay, you might argue if I do it in Excel, I can just drag and select and calculate the BMI via formula, it is much easier. But let's say you have, I don't know, you want to automate this process, it's better to do it in Python. Okay, if you have to do this every single day and you don't want to do it manually every time, just do it like this. Okay, so right, that's the same thing. Let's say I want to do okay, I want to do it differently. I want to check, instead of just numbers, I want to know the body conditions. So I want to print out like underweight, normal, overweight, and obese. I can do this. Underweight. Oh, sorry. Normal, overweight, and obese. Okay. And okay, before I execute the functions, just to let you have a better idea of what I want to do. Okay, I want to select everyone with a BMI under 18.5. Okay, and to do so, I can do it this way. Just select my BMI column. Okay, do my conditions. I want everything under 18.5. After I run it, it will be a list of true or false. Okay, and if I bound my list of true or false with a square bracket, okay, it just shows me the table that satisfy the conditions. Okay. There is an alternative way to do it, which is use the log we talked about. And remember, we have a comma, and everything on the left is our row, everything on the right is our column. So we can do select BMI. Oh, actually, you don't have to do this. Just select everything with a colon, and then do df dot or df BMI under 18.5. Okay, it gives you the same thing. Any questions right here?
Who select only age and weight?
Okay, you want to select only age and weight. Just put square bracket, because you have two items, so it has to be a list. Okay, just do age and what? Age and weight. Age and okay, weight. Okay, that's how you do it.
Without using log?
If you don't want to do log, you can do it this way. It's a bit complicated. So BMI smaller than 18.5. Okay, now you have the entire table, and you have to do it like this. Age and weight. Sorry. Yeah, that's how you do it without log. Okay. To understand the code, okay, everything on the left gives you the table filtered by BMI smaller than 18.5. Okay. Everything on the right is okay. Easier to understand is to remove what's inside and put weight. Okay, if you do it this way, it's gonna select one of the column. Okay, if you add one more bracket, it also select one column, but you can see the face of it is different, because you're, instead of select one column, you are creating a data frame with one column only. Okay, so there are a subtle difference between the two. And if you want to do more than one column, just do BMI. Okay. Is that, you don't get it? Okay.
You're saying with one square bracket this means and two square bracket get bigger.
Okay, yes. How to put it? Okay, if you do it like this, it's gonna select one of the column.
What's the type of?
Oh, the type is a series. Okay, this is called a Pandas series. And if you put two square bracket, it's gonna be a Pandas data frame.
Is the series can more than one column?
No. If you want to select a series with more than one column, that's two series. Okay, then you have to do it separately. You have to select the first series separately, and then you select your second series. Because you can't have one series with another one, that's a data frame. Okay.
So always we have to use two square brackets.
If you have more than one column.
If we want to return it.
Yeah. If you put everything inside, I wish I can do it, but Pandas just don't allow me to do it. So we can't do it. Okay. Alright. So okay, I forget what I was talking about. Oh. Yeah, we want to find out the underweight, overweight, and obese groups. So basically how we do it is just okay, for everyone, like find out the number of people that is underweight, we just do a length of the data frames. Okay, I forgot to mention, if you want to find out the number of rows, you just do len, that is the length of the data frame. Okay. So if you cut it by a subset, it's gonna show you the underweight data frame and the data frame with multiple conditions, like bigger than 18.5 and smaller than 25. Okay, maybe I will type this out with you so you understand it better. Okay, so okay, everyone should understand what that means now. If I want to do two conditions, in Python you have to do it like this. Okay, that's two conditions. Bigger than 18.5 and smaller than 25. Okay, and if you want my data frame to satisfy these conditions, just bound the whole thing with a square bracket. Okay, that's how we do it.
Sorry, the G is it a G ahead or is it the and?
Which one?
Like to connect it to.
Oh, this is AND.
Okay. No,
Okay,
this looks like a G.
let me. I'll make it bigger. Okay. Oops, sorry.
So,
Yes. Okay, bear with me. It's my slow computer. Okay.
So if you type M A N G, that doesn't work.
I think I have to try it, because try this. Okay, it doesn't work. So probably it only work with AND. Yeah. That's by practice. Okay. Okay, I won't go over all the code, just to let you know this is how you get the subset of it. Okay. All right, let's skip this because it's not too important. Well, I'll teach you how to plot these kind of graphs later on. Or should I do it now? Okay, I'll teach you later on. Okay. Remember I talked about a series and their frame. So just now we talked about series. If let's say is one of the column of your data frame is called a series. If you have more than one column, it's called a data frame. Okay, you can specifically create a series, and it works something like a list. So just do pd.series and then put a list inside, and you create like a Pandas series. Okay. Or alternatively, you can specify an index for it. And so everything on the left would be what you specify. Okay. But personally, I don't think PD series is very useful. Always use a data frame if you can. And then, okay, let's say I created this dictionary, and I can put it in a series, and it become something like this. Okay, like Austin, Boston, Chicago, New York, and you have all the numbers you want. Okay, and after you created your series, you can select it by index. Okay, city is Chicago, or you can do multiple indexing. But again, try not to use a series. Always try to use a data frame, and that works the same way of how you cut the series by conditions. Okay, let's skip this one for now. Okay, sorry for a lot of series. Okay, let's go over with reading data. This is more important because we don't really create data from the code. Okay, we collect data or read data from a data source, and that usually is reading from a CSV. Okay, and I think I showed it several times. How you read a CSV is copy the URL and then read it by putting the URL into pd.read CSV. Okay, this is the stock price for Tesla. Okay, and one thing to note is I use conditions called past date equals true. Okay, now my index become date, and this is all the high and low for the stock price for Tesla. Okay, we have the volume and we have the price. Okay, and now this is a much bigger data set than what you've seen. And good practice is always check the shape of the data. Okay, so actually not very big. So it's 2 rows, 22 rows, and 6 columns. Okay. And let's say now I want to plot a graph. Okay, based on the price and the date. Okay. I'll type it with you. So we need a library called matplotlib. Matplotlib.pyplot as plt. Okay, and then we specify our data frame that we want to plot. And let's say I care about okay, Okay, I care about two things. I care about the adjusted closing price. Okay, and the what do I care? And the high price. Okay. So I do y adj close and then high. Okay, something went wrong. Let me check. Okay, it's just a typo. Okay, you probably will have a weird line that doesn't show you the graph. To make the graph shows, just to put plt.show. Okay, now it plots you a very nice graph for the closing or the high price. Yep.
I think I've got some error.
What is the error?
User warning panel does not allow columns to be created via new attribute name.
Did you define a new attribute name?
I don't think so, no.
Anyone else have got the same error? Okay. Okay, let's try another way. Try it without the past dates as true. Okay. I'll remove this as well. Okay, now my past date is not true, so my index becomes normal, and I can try a different way. Try to plot against close. Okay, but I know this looks weird, but does this line work for you guys? Without passing the the element. So instead of with the parameters, just put pd.readcsv URL and try to run the plotting again.
Sorry.
Does everyone has the same error?
Just the warning works, but
it works with the warning. Anyone else has a working code?
It's work, but just the warning.
What's the warning saying?
Pandas allow columns to be created via.
Oh, columns to be created. Okay, I'll find out why with a different computer. I didn't know why my computer allowed me to do it. Okay. Okay, I'll keep on with the class first, and I'll find out why after the class. Okay, anyway, if this works, this is what you expected to get. So the x-axis will be a date, and then you will have all the price. Okay, and remember I said Pandas is very time series friendly, and that's the reason why. It just helps you to plot graph very easily. Okay, let's say I care about the different stuff. Okay. If I care about adjusted close and the volume, okay, I'll just plot a graph like this. And what I'm doing right now is just like data explorations. So if I look at the number, it's very hard to see any pattern. But if you print it out, plot it to a graph, it's much easier to spot the pattern. Okay. Okay, let's say I want to find a mean for your closing price. You just do Tesla square bracket close dot mean. Okay, or if I want to get a very complex statistics, just do dot describe and just get everything for you. like mean, standard deviation, max, minimum. Okay, these kind of stats. Okay. Okay, here comes the exercise. Try to read the URL, paste it to a Pandas data frame, and do all the visualizations. Yeah, basically, it's just what I did above, but I asked you to do it again manually. But this time with a much bigger data sets. Okay, this is slightly different. So the date is different and the size is much bigger. Okay, probably we don't have enough time to do the exercise now, so I'll just go over now. Okay. So let's say if you want to plot, sorry. Yeah.
Yeah, I don't understand. No, start.
Above?
No,
Below.
the test that is the first one.
Oh, this one.
Yeah.
Okay. Tesla days.open.
Okay. Yeah, you are just the open plan.
Oops. Sorry. What did I put? Okay, probably this is a typo.
Okay.
Yeah, I didn't meant to put this. Sorry for that. And then this is just to plot the graph. And then this is just how you plot the close and open. Okay. It was a good time to buy Tesla. And then okay, here is another exercise. Read the CSV from the list. So now I have another CSV, and let's say I want to read it into Pandas. You do it by pd.read CSV, and like this. Okay, now this is a different datasets with a lot of country and region. So just a very simple dataset telling you which country is in Africa. Okay, and I'll call this df. Okay, if you want to pick the first few lines, how are you going to do it? Head, right. Okay, how about the last few lines? Tail. Okay, how about the size of it? Shape. Okay. Oh, sorry. For shape, it doesn't need the bracket. How about if I only want to select the country with which is in Africa? Any clue? Describe?
No, square bracket.
A square bracket region. Okay, and then
No,
equals to Africa.
I have it.
What else?
Yeah, of course.
Yeah, df bracket, the whole thing. Okay, now I have my subset of country with only Africa. Okay, one more thing I didn't tell you guys is if you do df.region, sorry, and do value counts. Okay, this is very handy. Just give you a summary of how many countries are from Africa, how many are from Asia. Okay, this is just a quick overview of the distributions. Okay.
Sorry, when you so all you have to do is just put the name of the name and dot value count, and then it'll help you categorize it. The columns, like if I give the column index of region, so if I have a what do you call it, a column index called name, and it just changes the name, dot value, count, it'll just show all the.
Actually, do you mean like the dot? You don't.
Yeah,
say
like
dot.
basically like so
Yes.
what I mean is if I do df and the name of a column I'm giving
Yes.
dot value count, it will just count every.
Yeah, count every members of the list. And basically, dot, like square bracket region, is the same as dot region. Okay, this two is the same thing. Okay, this two give you the same thing, but this is where most people get confused, because Pandas design it for you to type it handily. So you just can do a dot and then you can find out the column. Okay, but this got duplicated by a lot of different functions. Like if you do dot shape, it actually means getting the shape. But if you do dot one of the columns, let's say dot region, then now I'm selecting a column instead of getting the shape. Okay, so like if you just learn it, try not to confuse yourself. Try to do it with the square bracket. Okay, that's less confusing, I think. Okay. Okay, just another example. Let's say I want to build my own data frame. Okay, I just want to build a football data frame. Okay, with my year, team, how many times I win, how many times I lose. Again, I just put it into a dictionary. Okay. And again, if I wanna, okay, this is my the hangman word list. Okay, this is a list you can randomly select. And let's say I want to do a table that count how many words are there in the list. Again, I can just define a to list and put them into their frame, like this. Okay. Okay, one thing I didn't talk about is how to read CSV from your local file. Okay, I always read it from internet. Okay, if you want to access your own computer, try this library called import OS. OS stands for operating system. Okay, if you do os.get cwd, which is current working directory, it just gives you your current directory. Okay, and if you do os.list directory, it's gonna list out all your stuff on your directory. Okay, and let's say I have a CSV on my own directory, or I want to write something to my own computer. Okay, this is my data frame. If I want to write it to my computer, just do dot to CSV. Okay, I can call it df.csv. Write it. Okay, now just check my directory. Okay, I created this CSV. Okay, and that's how you write your CSV to your local file. Any questions for here? And if you want to read your own CSV that you just wrote, just do pd.read CSV and then read the file you just created. Okay, you can do pd.read CSV, and then I just created this df.csv. So I just do df.csv. Okay, now I just read the file I just created. Okay. You might notice now you have one weird column, because I write my index as well. Okay. Okay, let's skip this one. You can actually write it to Excel as well. Like instead of CSV, you can write it to .xlsx. But you have to have Excel installed in your own computer. Well, I don't. I'll try to see if it works. So import open py Excel. Okay, it doesn't work. Oh, try this. Yeah, you have to have Excel installed to make this work. Okay. I think I can read. Okay, if you just wrote your I'll try to see if it works. Okay, because I didn't create my football.xlsx data, so I can't do it with Excel. But if you have Excel in your computer, probably you can just read the file and specify which sheet you want the data to be. Okay, any questions for now? Okay, Pandas can do web scraping. Okay, let's say you have football fans. You want to get all these tables. Okay, and then this used to work for me, but I updated some library, so it doesn't work on my computer. I'm not sure if you guys can run this code properly. Does it work on your computer? It works? Okay. So that's how you read HTML to your data frame. Okay. Anyone else got this working? Okay. Then it's my problem. Okay. And so that's just the handy way of getting data from the internet. And let's say you want to sort your table. You can do it by .sort values. Another handy stuff. And just specify the column you want to sort. Okay. Okay, this is just another example that helps you to read the table. Let's say, I don't know if that works for me. Okay, that works for me. Okay, so let's say that you have a URL, you just do .read table. And the reason why this is separated by tab is because the URL is TSV, tab separated. Okay, let's see if we have something more interesting. Okay, can you guys read this line? Wiki US read HTML. Working for everyone? Okay. And then okay, let's skip these guys.
Why do you add the square brackets with the 0?
Okay, the reason why I have this is, okay, let's go to the link. Okay, I have this list right on my Wikipedia page, but this is also a table. Okay, so if you want to get the first table, do a square bracket 0. Okay. And then I'll try to see if this works. Okay. Okay, let's say if I put a different separator in here. I don't know if you do it in Excel, there's a function called split the cell by something. Okay, let's say you have a table like this. This is actually a comma separated file. You can see every line is separated by a comma. And if you want to make these guys human readable, try to specify your separator as comma. Then it will become a nice format. Okay. Okay, let's skip this one. Just another example. This is the same one. So now I have the same country and region datasets. That's how you count the number of regions. And let's say I care about China and I want to find the region of China. You can do same thing. Countries.country equals China, and you can find the region is equals to Asia. And if you want to specify, sorry, the column, just do it this way. Okay. Now I forgot to remove the answer for all the exercise. Okay, let's say if I want to. Okay, let's say if I want to select Austria, how can I do it? I want to find the region of Austria. Okay, just do countries.country equals Austria, and then bound the entire thing by. Okay, now I just filter by Austria. Okay. Let's say I have another example for a stock market. Okay, this is my my data. Okay, I have AAPLX and AAPLY. Basically, it's the price and the date. Okay, let's say I want to convert this column to date time. Okay, the way to do it is do a PD dot to date time. Okay, then everything become a date. Okay. And then you can now plot it by graph. Okay. Just do, and you can plot it. Okay. Okay, let's skip these guys, and then okay, and then at last we have our homework. Okay, so this homework is meant to be done by next class, but if you want, we can delay it to next Thursday, so we've got more time to prepare for this. So basically, this class is you're given a very big file, and this file is the entire book of Harry Potter. Okay, if you use this URL, sorry. Okay, now you have the entire book of Harry Potter. And text is unstructured data because it's meant to be for a human, but not to be for a computer. So now your task is to put this into Pandas. And what I want you to do is count the number of paragraph, sentence, word, and alphabets, and then count the number of time the words got repeated in the text file. And then the last one is very challenging. I want you to find out these characters, which pair interact the most. So you have Harry, Ron, Voldemort, Cyrus, Hermione, and the other characters. And you can actually plot a graph using Pandas based on this.
By interact.
Interact means if they talk to each other. So basically, sorry, interact means if they happen in the same sentence.
Oh, happen in the same sentence.
Yeah,
okay.
if the two names appear in the same sentence.
Oh, okay.
So basically, it'd be like Harry said to.
Yeah.
As long as it's within that one sentence.
Yes. Or actually, whatever way you define it. If they, that's how I meant by interact.
Okay.
Okay, just some clue. Okay, if you don't know how to put stuff like words into Pandas, just try these two functions: read table or just read FWF.
Can I ask a question about the thing that just like the raw
Yeah.
file?
Yes.
What is supposedly each line like what is the
separator.
The separator? Yeah. It's like so by JK Rowling, what is that considered? Because it's normally like you said, it's one big text file.
Yes. Okay. The way to find this out is try to go to the text file and try inspect. Okay. And then in here, actually, every line is separated by a /n, if you know what I mean. And you can see, actually, every line has a very clean structure. And try inspect, like the first. How do I do it? I.log first line. Okay, this is your first line, and let's say the 100th line. Sorry, if you want to visualize it better, you have to do it like this. Okay, so basically